Welcome to my presentation held at the 11th Conference on Advanced Building Skins in October 2016, Bern in Switzerland. My name is Dr. Daniel Friedrich and I'm reporting about latest study results conducted by Compolytics, Composite, Polymer and Polymer Analytics. And my presentation is titled Sustainable Bioplastics-Based Cladding. In this scope, I would like to start by giving you an introduction about what are these bio-based cladding and in particular wood plastic composite. Then giving you some preparative investigations about the latest study to find out the most decisive product properties for these novel WPC cladding products. Then also giving you some insights about laboratory testing for performance of such WPC cladding, and then concluding the lessons learned by giving you some insights about value-added development of WPC cladding for future research and development projects. So let's start with the question, what are wood plastic composites? They are bio-based and they are a new generation of plastics composite materials. So there is a thermoplastic matrix polymer which is petrochemical based like polypropylene, polyethylene or polyvinyl chloride, in which wood fibers up to 80% by volume are added, making them highly bio-based, and then also some additives are added like liquids or powders for improving the bonding between the hydrophilic wood fibers and the hydrophobic polymers, but also for improving other properties like UV resistance, for example. And then we end up with such extruded WP profiles, hollow core or solid profiles, from which today are deckings are made or cladding for facades. There are already some products available in the market made from this novel WPC material, and we very often find decking boards and claddings as hollow core profiles, but using the same technology it's easy to make fencing panels out of it, and the latest developments, they turn to injection molded floor tiles for interior or for outdoor use. Looking at the figures describing the production volume, since this is a new material, we do not have regular figures, but taking those from 2012, we see that here in the European Union we have at least something like 2.5 million tons as bio-based plastic composite, consisting of WPC but also as natural fiber reinforced plastics. They are mostly used as decking, but also partly in automotive, in siding and fencing, where also the claddings belong to, and other technical applications with a minor priority. In furniture, sometimes chairs are made from this compound material, and consumer products, so products for daily use, but very minor volumes here. So you can see that the most volumes, they go into decking, which is a linearly extruded profile. So when we want to develop building products out of WPC, it's important to take the current norms and standards into account, and here we find the regulation EU number 305/2011, which describes the basic prerequisites for development, starting with mechanical resistance and stability, but also fire resistance, healthiness, safety in use, and also some building physics properties like energy consumption and also noise protection. And very important, today's building products, they should also contain sustainable natural resources to make them at least bio-based. So this fits well to WPC. But many of these characteristics, they must be tested in order to find out what are the concrete values, and obviously mechanical resistance takes a priority here. So taking the structural fitness as the main point, we would then find further information in the, let's say, the German Landesbauordnung, if such products are used in German buildings. And here it is described who is responsible to cope about these prerequisites. And paragraph 3 says that building and building parts should be safe. There should be no danger for public safety, health and livelihood. And this is given if a building is stable. So who should ensure about the stability? It's the architects, structural engineers and the contractors. They are somehow liable that the building and the building parts, they are stable. And they are stable if they comply with norms and codes as described here. Well, if there is no facade engineer involved, it is at least the contractor who must ensure compliance. So whenever a contractor is buying a WPC product from his supplier, the contractor must get sure that the product is in conformance with the current codes and standards. And also site managers must ensure that the erected building and building parts at least correspond with the planner's design documents, because the planner should have taken all these standards into account. So we then conducted a study, and we were interested in knowing what detailed properties are mentioned in today's approval documents for facade cladding products used in the European Union. And there are indeed approval documents for such products which are obviously in compliance with these 7 categories mentioned in the EU regulation 305. And we went through all these available documents. They were not valid or given for WPC because this is a new material. There do not yet exist such approval documents, but at least for other products like fiber cement panels or like high pressure laminates and metal sheets, all these are already regulated for use as facade material. And then we were calculating weighing factors which could then be used for elaborating a utility analysis. And we found that the highest loading with 0.17 is given by information about connection resistance. Then the second range was taken with 0.13 by the modulus of rupture in bending. So the bending modulus of these materials are obviously highly interesting and important. At third, there is the surface load, the applicable wind load, weighing with a factor 0.10, and then there is the section modulus, so obviously the shape also is crucial, weighing with 0.09. They all in sum have a total weighing of about 0.50, so take already 50% of all available weighings, and all the others, they are split over a wide range of other single factors which should be taken into account. But obviously such mechanical resistance values, they matter most in approval documents for facade products. Here is the reference where you can find more information about this study. It is already published in the Journal of Case Studies in Structural Engineering. Then we conducted another study. It was a laboratory testing where we tested 2 different WPC cladding profiles which were already available in the market, but yet without any approval document. And we wanted to know what are concrete load values for wind loads applicable to these profiles when installed on facades. And we were testing them for several spans, 400, 500, 600 and 700 meters span breadth of the subconstruction, because these are usual spans realized in facade building. And you can see here that the applicable wind loads, which were gathered from a foil back testing, which is well described already in standards. And here we measure the deflection and then also the braking loads in kilonewtons per square meters, which equal to characteristic wind loads. And you can see qualitatively, when the span is increased, then the applicable wind loads, they go down. In this case, for this test material WPC1 with 60% wood fibers and 40% plastics matrix, we have values from nearly 6 kilonewtons per square meters down to 3.8 kilonewtons per square meters with a wider span. This table is a summary of the test results for the product, or the test product number 1, which you have seen before on the previous slide. And this is the second profile we tested for. The main difference is the wall thickness, given here with 5 millimeters in the second type, and the first type have 3 millimeters, should have an effect on the measured ultimate wind load. And indeed, you can see here with a 400 millimeter wide span, we have 5.80 kilonewtons per square meter for the thinner wall thickness, and for the larger wall thickness we measured 12 kilonewtons per square meters, which in reality was even more, but we couldn't measure more with our device, so we stopped measuring at 12 kilonewtons here. And we see also the values go down with a wider span, and we also calculated the loading per screw, and the more screws are fixed per square meters, of course, the respective maximum loads per screw, they are also lower. What should be researched next is that we should learn more about the fixation mechanism. Obviously, this is the crucial point when it comes to failure of WPC cladding, and it makes sense to have a thicker wall, especially in the area around the fixations. But also we should learn more about durability aspects, and in order to be able to integrate as many wood fibers as possible. And this should then also be illustrated by an agent coefficient, which should be taken into account when designing such facades. Then we should also think about how the remaining petrochemical polymers can be substituted by biopolymers in order to end up with green composite facades, which would then be fully biodegradable. And the next projects which are in planning is the development of the bioregenerative facade by the use of grass fibers instead of wood fibers, and also the development of a window frame system using WPC as main material, and also finding out more possibilities how to use WPC in furniture production. This is a list of the used references in this presentation. And with this last slide, I would like to come to the end of this presentation. Thank you very much for your attention, and if you are seeking further information, please visit the Compolytics website. Thank you very much.